Hello, today I would like to present you this absolutely beautiful beefy isolation transformer from a company called Victron Energy. That model is capable of converting 3.6 kilowatt, so it is extremely beefy model. It's got built-in thermal protection, thermal control fan, and also got ability to be used as step up and step down transformer. So you've got isolation plus voltage conversion. You can, for example, grab 230 volts and also output 230 volt and use it as isolation transformer, for example, in your electronic lab or in marine application to prevent galvanic corrosion. Or you can grab 230 volts at input and step it down to 115 volts, so you can run your US appliance. The only thing is that you are not going to achieve a frequency conversion, so some very specific application might get problem, but most devices is going to be running just fine. Or you can do the opposite, so you can grab 115 volts and output 115 and do just isolation, or you can grab 115 volt and step it up to 230 volt, and this is what I would like to do. And we are going to connect this device by using internal jumper to achieve exactly that. Victron Energy use it for marine application, but of course you've got absolutely no problem in using that in your electronic lab. You can use it as an isolation transformer, you can do the conversion, everything you want you can do with it. So let's do a reveal. And this is how it presents. It is simple transformer, but as you can see, we've got lot of electronic inside, and I will tell you what they are doing because they are just great. Under that plate we've got transformer. It is extremely heavy, almost 30 kilograms. The transformer is toroidal type, so it's going to generate less loss than the regular iron core design. And let's take a look what we've got inside. From the front panel you've got access to those two elements, and they are fuses, automatic fuse for the input and the output. On that tiny wire you've got access to the probe that is measuring temp of the transformer. In case of overheating, over there we've got a fan, and it's going to be blowing air to cool it down. The absolutely most critical feature of that device is the slow start. And as you can see, we've got those beefy resistors. The idea is until magnetic field is going to be built up around the core of the transformer, for the AC is going to be completely short circuit, and it can blow extremely beefy fuses. It can blow up, and it will blow up your inverter because it will be like you stick two wires into the outlet. This is how much current it will pull. So that device contains electronic that is called slow start, and the relay is going to be first attaching the AC through those resistors. They are going to be limiting the amount of inrush current, and as the magnetic field is going to build up, it's going to be switching next relay, and your device is going to be operating as it should be. And this is the reason why you've got 4 relays and 4 set of those resistors. Absolutely beautiful. We also have got some control smaller transformer, most likely for those relays because they are running from 24 volts. So it is an absolutely beautiful design. Here we've got a pretty important jumper, and it's going to be bonding the input protective earth with the output, And also here we've got other terminals that are related to that process, so it can create an artificial protective earth for RCD breaker even if you are isolated. So yeah, those are more complicated stuff and should be done by electrician according to your regulations, but there is possibility and you can configure that. Here we've got our beefy blocks for the input and output, and now we are going to take a look at the user manual and we are going to see how to configure them. Primary and secondary side of your transformer is divided into two sections, and I deeply believe that it's using that half ratio. So if you go with a 230 volts as input, we are going to be bridging those two contacts and creating one beefy transformer. If we are using 115, then we are going to be connecting them in parallel. But I'm not planning to draw a schematic for that, but I believe this is what's going on. Here is input, so we've got live, neutral and protective earth. And this is configuration if we would like to get 230 volt input. Those are these four terminals, and we are going to be bridging them using jumper like this. But I'm not interested in 230 volt input, I'm interested in 230 volt output. So I'm going to join the two center pins. I'm grabbing my jumper and I'm connecting it here, just like that. Then we are taking a look at our 115 volt input, and you are going to be following that configuration if you would like to get 115 volt output. But we take a look at the input, and we are going to be connecting first and third, second and fourth. So we are going to grab our jumper, we grab the first terminal and the third one. Then we grab the fourth and the second one. Just like that, we made our jumpers, and of course you have to use the wire gauge that is going to be carrying all load. Now we are going to grab our AC cord that is going to be carrying 115 volt. I will route it through that grommet, and we are going to be removing the insulation. Now we are going to be connecting our input according to US color code. So the green is going to be our protective earth, black is going to be our live conductor, the phase, and the white is going to be neutral. This is what I read on the internet. Since we need to get a good contact, we are going to be using those tube and terminals, and we are going to be nicely crimping them. So we go like this, we're making sure that we can see some copper, and we nicely secure them like this, and it's going to make a perfect contact as we are going to be crimping it. Do not try to put it like this because it's going to be bending, and if you do not get a good contacts, then you are risking a fire hazard, and we definitely do not want that. We go like this and we nicely crimp it, and the same with our neutral. We go like this, we go like that, and we are going nicely crimp it. Absolutely beautiful job. I will start with our live. It go into the live terminal. We go like this and we nicely screw it in. I'm not sure what kind of force I should use, So I will go with a medium because I don't want to break the terminal block. Neutral is our white. Same situation, not too much, not too low. Protective earth, green. We nicely unscrew it. We nicely put it in. And same situation, not too hard, not enough. Absolutely beautiful. This is what you would like to see. Here I've got my beautiful German Schuko socket. Absolutely beautiful. I love that type of grounding. The protective earth. And I'm going to strip this wire using my favorite tool. We go like this. Just take a look how beautiful it goes. I'm going to route it through our grommet and we are going to be stripping the insulation. I'm wondering, does 3 at once are going to be a good job? Yes, of course. This is the device that you can put your faith at. And we are going to repeat our process with attaching the terminal crimping. We go like this. If you notice that I'm using thinner wires, that you are 100% correct, and that's because at the 230 volts we are going to be using half current that is required at the input. This is a simple math, but I will not be using full power because those wires are going to be too thin for 3.6 kilowatt, but I'm limited by my inverter, so I will never get the full power. The inverter is going to turn off first the live output, which in Europe is going to be a brown. Then we've got with neutral, which in Europe is going to be blue. We go like this. And the protective earth, which in Europe is yellow and green. We nicely connect it here. Okay. In my personal opinion, that looks absolutely beautiful. We've got them nicely covered, no accidental touch. And we can try turn it on, and it's going to be interesting. I will begin our test from going into continuity mode, just like that, and I'm going to make sure that the protective earth is connected properly. So this is protective earth on the US plug. And we've got a good connection. And on the German plug, this is protective earth. And I'm going to be making sure that we've got connection. And yes, we've got good connection. And I deeply believe we are ready to make our test. You might ask yourself where to plug it in Europe. And for that test, you need a device like this. It is a voltage converter built as the auto transformer. And here we've got the US output, here we've got the Europe, and it can step up and step down voltages. So we are going to just attach it like this, and I'm going to be powering it on. I'm going to grab my protective glasses and I'm going to be powering it on because I don't want anything to explode. Watch out. Relay click. Another relay click. So we definitely go from the using resistors and the transformer is being powered on. Let's try to measure our output. I'm going to be removing those protective elements. And what kind of voltage did we get? We are reading 244 volts, and it is absolutely beautiful value that came from my isolation transformer. So we've got absolutely beautiful proper value. Let me try to load it with something that we can use for testing. I've got this beautiful vintage lamp that is operated on 230 volts, 40 watt, and I'm going to attach it into our plug, and as you can see, the bulb is working as it should be, and I will try to present you how the difference in the input and output work. So I will go into 2 amp on the AC, I will zero it out, and I will show you the current flowing on the primary side. And as you can see, we've got 0.5 amp, and on the output, since we are using the higher voltage, it should be half of that. As you can see, we cut that current over than half, and that's because looks like we've got some losses at the idle on the transformer, but everything is working exactly as we expected. So thank you very much for watching. I hope you find that interesting. See you next time, and bye bye.